Determine the limit by interpreting it as the definition of the derivative. Limit as h goes to 0 of 1 over h minus 4 plus 1 over 4, all divided by h. This is of the form limit as h goes to 0 of f of a plus h minus f of a, all divided by h, which is the definition of the derivative, and therefore it is equal to f prime evaluated at a. So instead of working at the limit directly, we can, as an alternative, find the derivative of f of x and evaluate it at a. In order to do that, we need to determine f of x. That is determined by comparing this f of a plus h to the terms that have the h's with the constants, f of a plus h. Well, that's right now not in the form of a plus h. Instead, it's h minus 4. But what we can do is rewrite that as limit as h goes to 0 of 1 over, instead of saying h minus 4, let's say negative 4 plus h. It means the same thing, but it's now more in the form of a plus h. So there's our f of a plus h right here. In order to get f of x, we're going to take the entire a plus h, that's all of this, and replace it with x. And so our function will be 1 over x. Furthermore, we can compare the a plus h, and whatever's added to h is the a. A plus h, there's your a right there. It is a negative 4. We can now find the derivative of f of x, but before we do that, let's rewrite it as x raised to the first power in order to be able to use the power rule. And the derivative will be, bring down the power, negative 1. Subtract 1 from the power, negative 2. Derivative of the inside will be a 1 since it's just an x. We can rewrite this as negative 1 over x in the denominator as a positive exponent. There's f prime of x. Let's now evaluate that at a, f prime of negative 4, which will be negative 1 over negative 4 squared. Negative 1 over negative 4 squared. Negative 4 times negative 4 is positive 16. So we have negative 1 over 16, and that is what the result of this limit will be, a negative 1 over 16.